Hey, welcome back. So we're still talking about searching algorithms, but now we're talking about a different type, which has to do with searching for substrings in a larger string. So there are two that we're going to focus on, and the first one is the naive string search. I don't think there's actually a name for this. This is just the most basic, common way of doing this problem, and then we're going to see a better implementation that is definitely a little more complicated in the next two videos from now. But we're going to start with the basic solution. So imagine that you want to count the number of times a smaller string appears in a longer string. A straightforward approach involves checking pairs of characters individually. So imagine we have this string here. Harold said haha in Hamburg. So if we were searching for just a single character, like, I don't know, the letter I, for example, that's very easy. That's basically what we've done. You just do a linear search. You could treat this as an array, right? You just check, is this an I? Nope. Is this an I? Is this an I? Is this an I? Over and over until you find an I or until you hit the end. So that's nothing new. If we're searching for a single character, we can use what we've already done. Instead of accessing items in an array, we access using an index in the string, just like this, right? 0, and then we check 1, and then we check 2. But if we're checking for a pattern, for example, I want to see if HA, haha, is in there. That takes some more work because we're no longer just checking a single character against a single character. We're checking, okay, let's walk through the string, and it looks like we have an H, so that's a match, and then we have an A, oh, that's a match, and then an R, oh, not a match anymore. So then we start over, and we look for an H again. So I actually have a little diagram here. Imagine that this is our long string we're searching through, and we're trying to find OMG inside of this. So the simplest approach is going to involve, basically, if we put them next to one another, we're going to start by walking one character at a time. And we're just going to check, is this W here equal to the O at the beginning? Are these two characters the same? No. Okay, move on. Now we have a match. O is O. So now we move on to the second character. We're looking for an M. We don't find one. So we move on. W and O, we don't find that, so we move on again. Okay, O and O, that's a match. Now we move on to the next character, M and M. That's good. G and G, and we hit the end of our short string. We found a match. So now we add a counter, we increment something to keep track of how many matches we found. We found 1 so far. Now we move on to the M. So basically we do it for every single character here. And we start at the beginning of our smaller string and check it against every individual character in the longer string. So that's not a match, that's not a match, that's not a match. Now we have a match at the O, so then we check the next character, M. We check, there's still a match, G, and we increment. I don't know why this, when I made this slide, I just checked, these are the same size. Somehow there's some weird bug when it's being displayed. But these should count evenly. There's 2 matches. And that's what we want to do. We want to try and implement this naive string search. So there is a better way of doing this, but it involves a lot more code that we'll see in 2 videos from now. And it has a much fancier name. But this approach is one that just takes a couple lines, a couple loops. Let's walk through the pseudocode. So the idea, again, is for you to try and implement this on your own using the pseudocode if you have the time or willpower or energy. Here's the steps. So loop over the longer string. So I guess I didn't say define a function this time, but define a function that takes 2 strings and just call it maybe string search. It takes the larger string and then the pattern that we're looking for. And then you loop over each character in the longer string, and then we have another loop over the shorter string. And then we just check. Basically, if the characters don't match, break out of the inner loop, so stop. And if they do match, if we find a match for O, for example, in OMG, then you move on to the next character. Keep going until you hit the end of the short string. And if you do hit the end of that short string, that means that you found a match. So if you complete the inner loop, find a match, increment the count of matches, and then return the count at the end. And so if count should start at 0, we don't need to have any special error handling. If there are no matches, count stays at 0. So just return the count at the end. So hopefully that makes sense. Loop over the longer string, inside of that loop, a nested loop over the shorter string. And then if you make it to the end of that shorter string and you haven't broken out yet, then add 1 to the counter. Okay, so give it a shot. In the next video, we'll have a solution.